Hello friends, welcome back to the tutorial. Our next topic is finite automata with output. Till now we have studied NFA and DFA. NFA and DFA, when they read any string of input symbols, they either reject it or accept it. They don't give any output. Now we have two finite automata which can give output. One is Moore machine and other is Moore machine. In Moore machine, output depends on the present state of machine. Right? Here, output which machine gives is independent of the input which machine reads. Right? So mathematically, it's a six-tuple machine. Suppose there is a Moore machine MO, then it is a six-tuple. Q, sigma, triangle, delta, lambda and Q0. Here Q0 is initial state of Moore machine. And Q, capital Q, is a set of states. It is a finite set. The sigma is set of input symbols which Moore machine can read. It is also a finite set. Triangle is a set of outputs which this machine gives as an output, right? It is a set of outputs, so it is also a finite set. Next is a delta. Delta is a transition function. It takes two arguments: first present state, second input symbol, and it gives next state as an output. Suppose machine is in a particular state Q1 and it reads an input symbol A and jumps to state Q2. Then mathematically it is represented as like this: delta Q1 A. Here it will take two arguments. First is present state and the input symbol it reads, and its output would be the next state Q2, right? After delta, this is lambda. Lambda is a output function. It gives the output associated with each state, right? It takes only one argument, that is present state, and it gives the output associated with this present state, and that output, whatever it gives, belongs to this finite set of output, that is triangle, and Q0 is the initial state of Moore machine. Here, unlike DFA and NFA, Moore machine doesn't have any final state. Next is the representation of Moore machine. Here it is a Moore machine which is represented in tabular form. Here the states are mentioned, and these are two inputs which this machine can read, either 0 or 1, right? When machine its initial state is also mentioned by putting an arrow before it. Here an arrow has been put before Q0. It means Q0 is the initial state of Moore machine. So when the machine's present state is Q0 and it reads an input 0, then it will jump to state Q3. Here the entries, these entries represent the next state of machine when it will read the input which has been labeled here. When it reads 0, then machine from whose present state is Q3 and suppose it reads 0, it will jump to Q3. When it reads 1, then machine from Q3 will jump to Q0, right? So in these two columns, next state means transitions of Moore has been represented. Now this column represents the output associated with the present state. Here 0 is associated with state Q0, 1 is associated with state Q1, and 0 and 0 are associated with states Q2 and Q3 respectively. Now we can represent this Moore machine graphically also. When we represent it by a graph, then states are represented by the nodes of that graph and transitions are represented by arrows. Now here we have 4 states in this Moore machine. So when we represent it graphically by some graph, then that graph must have 4 nodes, and the output associated with the states must also be mentioned in these nodes. Here 0 is associated with Q0 state, so here I have written 0 in the node along with Q0. So look at here, 1 is associated with the state Q1, so 1 should also be written in a node which represents the state Q1. Now see the transition. When machine is in state Q0 and it reads 0, it jumps to Q3 state. So I have represented it by this arrow. This transition is represented by arrow, and it is labeled by input symbol. It means on reading 0, machine will jump from Q0 to Q3. Now see its transition for input 1. For input 1, it will jump to state Q1. Now the transition of Q1. When it reads 0, it will remain in a state Q1. When it reads 1, it will jump to state Q2. Now see the transition of Q2. Q2, when it reads 0, it remains here in the Q2 state. When it reads 1, it jumps to Q3 state. Now we have to represent the transitions of Q3 in this graph. When it reads 0, it remains in Q3, but when it reads 1, it jumps to Q0 state. So this is the graphical representation of this Moore machine. Now one more thing, we must put an arrow before initial state. Here Q0 is initial state, so here I have put an arrow before this state to show that Q0 is initial state of this Moore machine. Thank you very much.